Let's take a look at several different examples on solving linear functions. So we're going to solve all of these problems by using inverse operations. Let's take a look at the first problem. We're given 5x divided by 2 is equal to 13, and we want to solve for x. There are two ways that you can approach this problem. A lot of students get scared when they see fractions. So one thing that you can do is you can rewrite this fraction. So 5x over 2, I can rewrite that as 5 over 2 times x is equal to 13. Okay, now our goal is to isolate x, get x by itself. And right now, x is not by itself because it's attached to 5 halves by multiplication. So how do I undo 5 halves so that I'm left with just 1x instead of 5 halves x? Well, we know that anytime we have a fraction, if we take a fraction and multiply it by its reciprocal, and reciprocal means when you invert the numerator and the denominator, what ends up happening is when you multiply a fraction by its inverse, is it starts to cancel out. So 2 times 5 is 10, and 5 times 2 is 10, but 10 over 10 is just 1. So that means that 2/5 times 5 halves is equal to 1, and 1 times x, we're left with just x. Okay? All right, but in algebra, whatever you do to one side, you have to make sure you do the same exact thing to the other side. So if I multiply 2 over 5 on the left, I also have to multiply 2 over 5 on the right. And another way of thinking about how this cancels out is you also know that 2 divided by 2 is 1, and 5 divided by 5 is 1. So 1 times 1 is 1 in the numerator, 1 times 1 is 1 in the denominator, leaving us with 1 times x, which is 1x. And then on the right here, let's go ahead and multiply this out. So we get 13 times 2, which is 26 over 5. And you can just leave your answer like this. You can leave it as 26/5. Or if you want to convert it to a decimal, that's fine. You can convert it to a decimal, but it's really not necessary. Okay? But again, if you wanted to, you can rewrite this as x is equal to 5.2. Okay? All right, so that's one way of approaching a problem dealing with fractions. The other way to approach this problem is to rewrite it. So I'll show you on the right-hand side here. So another way to think of 5x over 2 is equal to 13 is we know that every whole number, or any number, doesn't necessarily have to be a whole number, but any number can be written as a fraction by simply putting it over 1. Okay? So like 2.5 is the same thing as 2.5 over 1. Okay? A is the same thing as a over 1. So we can make any number a fraction by simply putting it over 1. Now what's nice about doing this is now we have a fraction equal to another fraction. So we can solve this rational expression, and we can do that by what's called cross multiplying. But if you think about what you're doing when you're cross multiplying is you're still using inverse operations. Okay? So when I cross multiply, right, I multiply 1 times 5x, and on the right here, I have 2 times 13, okay? So 1 times 5x is just 5x, and then 2 times 13 is 26, and now I'm left with 5x is equal to 26. I still have to solve for x, trying to get x by itself. Notice that x is attached to 5 by multiplication. So to undo that, its inverse would be to divide it by 5, because 5 over 5 is equal to 1. That cancels out. But whatever I do on the left-hand side, I got to make sure I do the same thing on the right-hand side. So then x is equal to 26 over 5, which is the same thing as what we got over here, which is the same thing as 5.2. Okay? All right, I want to go back to this idea of cross-multiplying. So what are we really doing when we're cross-multiplying? I'm going to rewrite this problem. 5x over 2 is equal to 13 over 1. So if we think about what we did when we cross-multiplied is what we're trying to do is we're trying to get rid of these denominators. So on the left here, what if I want to get rid of this denominator of 2? How would I undo it? How would I get rid of it mathematically? So mathematically, what I'm doing is I'm going to multiply this. Think of this as 1 over 2. I'm going to multiply it by its reciprocal, which is 2 over 1. Right? So what happens is the 2 cancels out, and I'm left with 1 on the left. But if I multiply the left-hand side by 2, I also have to multiply the right-hand side by 2. So notice that what we have on the right-hand side is the same thing as what we did when we cross-multiplied down here. Okay, let me go ahead and finish this, rewrite this. So now I have 5x is equal to 13 over 1 times 2. Okay, all right, and now I have this 1. I want to get rid of it or undo it. So that's the same thing as multiplying the right-hand side by 1. So that cancels out. You can think of that as 1 over 1. But whatever I do on the right-hand side, I got to make sure I do the same thing on the left-hand side. Okay, so notice that by doing that, we end up with what we have over here. I've got 1 times 5x, which is exactly what we did over here. So let me rewrite this. That gives me 5x is equal to 13 times 2. So 5x is equal to 26. And notice that we get the same thing. Okay, so that's what allows you to cross-multiply. So mathematically, when you're cross-multiplying, you are in fact using inverse operations to solve for your unknown variable. Okay? All right, we'll approach the next problem in the next video.